Today we are covering lesson 84 and learning about solving rational equations. So first let's review what is a rational function. So we have already done quite a bit of work with rational functions and simplifying rational functions. So remember that a rational function is simply a function that is a fraction. So we have some expression in the numerator or a number and some expression in the denominator, because a rational number can always be expressed as a fraction. So that's how we call rational functions what we call them. And remember that one of the most important things about rational functions is that the denominator is not allowed to be equal to 0. So when we are simplifying rational functions, we always had to take that extra step to find any excluded values from the denominator. So now we're going to be looking at solving rational equations. So not just a rational expression or rational function, but we're going to actually set it equal to something and solve for the variable. And so there are a few methods that we can use, either by themselves individually, or we can combine them together to solve these rational equations. So one of the methods that we can use is cross multiplying. So this is a technique that has been used in math for many years of your education now in terms of simplifying fractions and solving equations. So cross multiplying is always an option when we have fractions. We can also eliminate the denominator. So sometimes we can eliminate the denominator altogether as we are solving these, and we can do this by either multiplying by just a common denominator or multiplying by the least common denominator. And sometimes, especially this method, requires us to factor or simplify first. So I'm going to put a little bit of a note here that sometimes we have to factor or simplify part of it. Let me spell that right. Simplify. Factor or simplify first. So just like with any other equation solving techniques that we have learned up until now, sometimes we need to do some simplification work, which might include factoring or other things, before we can actually get to the solving part. So that little note is nothing particularly new. It's just a reminder that that principle applies to these problems as well. So let's look at a couple of examples. Let's look at our first one. We want to solve this rational equation. 1 over x plus 1 over x minus 8 is equal to 1/3. So we know that this is a rational equation because we have these fractions with variables in at least the denominator. So if you're ever wondering, how do I identify a rational equation, this is how. As we talked about before, it includes one or more rational expressions. Now, as we're looking at this, you might think, okay, well, which one of the techniques should I use on this particular equation? Well, cross-multiplying, the first technique I mentioned, would be difficult. Because remember that cross-multiplying, let's take a little bit of a rabbit trail here to remind ourselves what cross-multiplying is. So if we have two fractions that are equal to each other, we can cross-multiply. We can say that a times z is equal to b times y. And that's cross-multiplying. But we can't cross-multiply if we have more than one fraction on either side of the equation. And on this side of the equation, we have two fractions. So either we need to combine them together with a common denominator, or we need to use a different technique. And when there's more than one fraction on at least one side of the equation, I prefer to just use the least common denominator, or LCD as we sometimes abbreviate it. It's just a little bit less work. And in this case, I look at all the denominators that I have. And sometimes I might need to do some factoring before I can identify the least common denominator. So keep that in mind. In this case, there's nothing that can be factored. It's all as simple as it can be. So the least common denominator amongst all the fractions in the whole expression, we have to look at all of them, remember our rules for finding least common denominators, is going to be 3 times x times the expression x minus 8. And notice, because the x minus 8 is a whole expression in the denominator by itself, we have to include it that way in the least common denominator. We can't just use just x or just 8. We have to include the whole expression in the least common denominator. And so now I need to multiply both sides of the equation by that least common denominator. So I need to multiply this side by 3x times x minus 8, and then the other side by 3x times x minus 8. So if I do that, I use the distributive property on the left-hand side, and this is going to eliminate the x. And so I'm going to be left with 3 times x minus 8 over 1, because the x's have canceled out. So that's just 3 times x minus 8. And then plus, over the next term, the x minus 8 term is going to cancel out. So I'm going to be left with 3 times x, again over 1, but we don't write that. So that's what I have on the left-hand side. On the right, the 3 is going to cancel out. These two 3's are going to cancel out. So I'm going to be left with x times x minus 8. So now, by using the least common denominator, I have eliminated the denominators. And again, in this problem, we didn't have to do any simplifying or factoring before we could do that step, but sometimes you will. So just because in this one example, I sort of jumped right into the least common denominator, doesn't mean that it will always be the case. Sometimes we might have to factor first, so just keep an eye out for that. But let's continue with this problem now. So from here, this is an equation that I know that you can solve. This is not anything that you haven't seen before. So I'm going to go through the steps fairly quickly. Of course, we're going to simplify first. 3 times x minus 3 times 8 is 24 plus 3x. And that's equal to x squared minus 8x. So over here I can combine the 3x terms into 6x minus 24 is equal to 8x squared minus 8, or x squared minus 8x. Now I see that I have the beginnings of a quadratic equation here. I have my highest term is x squared, and then I have some x terms, and then I have a constant term. So I'm going to go ahead and move the x squared term to the other side, as well as the 8x term, and just basically combine all the terms on one side of the equation so that I can set the whole thing equal to 0, because that is how we solve quadratic equations, right? So for the sake of having room on my board, I'm going to erase all that work, but I know that you have it in your notes that you're taking as you follow along. So rearranging those terms, I have x squared minus 14x once I take the 6x and the 8x and add them together. And then I have plus 24, and that ends up being equal to 0 once I've moved everything over and combined it onto one side. And now, in order to solve a quadratic equation, I need to factor it, right? And so this factors as x minus 12 times x minus 2 equal to 0. And now I know that x has to be either equal to 12 or x has to be equal to 2. Now, when I'm solving rational equations, I need to check my answers always. And here's why. Sometimes, even if we are doing mathematically legal steps, every step of the way we've not made any mistakes, the fact that we started out with fractions and we're manipulating the equation can sometimes lead to what is called extraneous solutions. And sometimes the final equation that we come up with, because we have changed it to not be a fraction form anymore, it can have some values that might cause the original equation to either be untrue or to have a zero somewhere in the denominator. And so for these rational equations, checking your answers is not optional. We have to plug back in our answers, or answer if we only got one, however many answers we got, back into the original equation to make sure that they still make it work. And if And that means that this is a great candidate for cross multiplying. And so if I do that, I multiply this direction, 2 times x minus 1. And then we multiply the other direction, 1 times x squared minus x. So on this side I have 2x minus 2, and then I have x squared minus x. So again, I have eliminated the fraction format, if you will, of the equation, which is good for solving. And now I just need to move through the solving steps. And again, you're going to see the fact that we oftentimes have quadratics that come up as we're doing that. And that's exactly what we have here. So whenever we're solving quadratics, remember we want to put it in standard form on one side of the equal sign and have it set equal to 0. So in order to do that, I would need to subtract an x squared from both sides and add an x to both sides. So this side will end up being 0, and all the other terms are collected on the other side. So if I do that, I have x squared minus 3x plus 2 is equal to 0. And then I factor x minus 2 times x minus 1, and that's equal to 0. So x is equal to either 2 or x is equal to 1. Now, if I go to plug these back into the original equation, I can already see that I'm going to have a problem. Let's look at x minus 1 in particular, or x is equal to 1 in particular. So if I substitute in x is equal to 1 everywhere I have an x, 1, 1, and 1, I see immediately that this causes the denominator of both of these fractions to be equal to 0, because 1 minus 1 is 0 and 1 minus 1 is 0. So x is equal to 1 is what's called an extraneous solution, as we just defined it in our last problem. And it's not actually part of the solution set. So the only solution that works for this rational equation is x is equal to 2. And that is it for this lesson, and I'll see you next time.